So we can use our skills of reciprocals now to graph cosecant and secant and cotangent. So we're going to follow the same ideas as before. Draw the original graph first. Then draw all the asymptotes we can. Then look for nice points and see where they go. And then draw a graph. So here's our first one. Our graph of sine. It's already drawn for us here. Are we going to have any vertical asymptotes? We have vertical asymptotes when? Whenever we have x-intercepts. We'll have one here. We'll have one there. We're going to have a lot of them. And we can label them x equals 0, x equals pi, x equals 2 pi. Are we going to have a horizontal asymptote? Yes. And how do we know that? Probably not. Do our y values go up forever? No. Or down forever? No. So there will be no asymptote at y equals 0. Yes. It just matters if at one place it gets bigger forever. At least one. But this one stays between -1 and 1, so there'll be no horizontal asymptote. Do you know any points on sine of x that are nice? Yes. Like, for example, what point is this one? Something comma 1, what comma 1? Pi over 2 comma 1. And what's going to happen at that point when you do the reciprocal? It's going to stay the same. Can you see that all of these points where y is 1 are going to stay the same? And what about the bottom, the minimum points? Are they going to change? All of these points where y is -1, when you do the reciprocal, you're going to get 1 over -1. Those points are going to stay the same. Okay. Let's think about some other points that we know. What about this point right here? What's the coordinates of that point? Close. The y value is a half. What sign gives us a half? Think about your pi plate. Pi over 4 gives you root 2 over 2. Pi over 6 gives us a half for sine. So if I have pi over 6 comma half on my original graph, then on my reciprocal graph, I'm going to have pi over 6 comma 2 over 1. We do the reciprocal of the y value. Can you see that there's lots of places where the y value is a half? In fact, these will all be 2 then when you do the reciprocal. And the same thing could be said for -1/2. And so what we get in the end, once we draw things towards our asymptotes, is our cosecant graph. Looks like a bunch of mini parabolas. Like just a little part of it? Yeah, if you know, they will accept it on the exam. If you know this point right here, right, this is your key points, and then just draw it up, that'll be fine. Okay? But if at this point, the reason I chose pi over 6 comma half is because sometimes when you just had this point, someone's wondering, well, do I go down towards the asymptote or up towards the asymptote? How do I know? And so by taking that extra point and thinking where does it go helps us realize what happens and how it goes towards the asymptotes. Okay, your job is to do secant, the next one. When you're finished, you can look up and see how you did. See if you got your asymptotes labeled correctly. Now, the graph of cotangent is a little bit different and acts a little bit differently because you can think of cotangent as 1 over tan, and that's what we're going to use to graph most of it, is think of the reciprocal graph of 1 over tan. But we can also think of the cotangent graph as cos over sine, because that's also true. You know that cotangent is equal to 1 over tan, and cotangent is equal to cos over sine, but depending on which of those versions we think about will cause our graph to be slightly different. So things start off normally with cotangent. Once you graph tangent, you say wherever tangent is equal to 0, so all of these points here, 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 these are all points where tangent is equal to 0. Well, if tangent is equal to 0, then cotangent is undefined. And so we get all of these asymptotes. Where tangent is equal to 0. And if we think of the graph of cotangent being equal to cos over sine, well, all of these values, starting at x equals 0, x equals pi, 2 pi, 3 pi, 4 pi, and their negatives, if you think about them, they're all values where sine is equal to 0. So they're non-permissible values for cos over sine as well. So those vertical asymptotes fit whichever interpretation you're thinking of, graphing cotangent as cos over sine or cotangent as 1 over tan. You're going to get those vertical asymptotes no matter what. Here is where things get a little bit different. Because normally, if you were graphing 1 over tan, you would look at the graph and say this graph goes up forever and down forever. So what would that mean? That would mean you would draw an asymptote at y equals 0. But on the cotangent graph, there isn't an asymptote at y equals 0. On the cotangent graph, we think more like cos over sine, and instead of having an asymptote at y equals 0, we actually have all of these points where tan had asymptotes, because all of these points are where cos is equal to 0. They're non-permissible values in tangents, but they become x-intercepts for the graph of cotangent. Now hopefully you're not using a black pen, because it's going to get really busy with the going on top of this already, because we've got lots of asymptotes and we're going to have another graph going on top. But if we think about some nice points on tangent, what point is that on tangent? Pi over 4 comma 1. And if you did the reciprocal of that, it would stay the same. Similarly, we have the point (3 pi over 4 comma negative 1). Those are values on your pie plate, yes.
So one of those points is going to
No, these points that I'm drawing are on my graph of tan. Right? Because they're on my tan graph. When tan is pi over 4, it's equal to 1. And so having those points, and we can draw those points in all the way along, wherever tan is equal to 1 or negative 1. And if you would do that, adding that point, those x-intercepts where cos is equal to 0, you can now draw your graph towards the asymptote. And you have your cotangent graph. So we use the idea of reciprocals, of graphing 1 over tan to get most of our graph, except we add those x-intercepts in. Yes? Again, if you just have the 1 and have the correct shape, that would be enough.